second set, 6 to 10. Very interesting puzzle. Sudoku you must have done, right? So similar to that, but using mathematical operation. All right. So the question is, Gracia asks a puzzle. Sorry, yeah, ask a puzzle enthusiast. Tamam. Okay, to solve a calcudoku. Okay, similar to Sudoku, calcudoku, which is a twist on the Sudoku puzzle. The puzzle involves mathematical operations, regions, and mathematical operation symbols. So you can see in this figure you have plus, divide, minus, right, multiply. Some squares are there, some dark squares, rectangles are there, some other squares are also there, or rectangles you can see. Okay, what is the rule of the puzzle? So rules are, there is one integer from 1 to 6 allowed to be put in each cell of the grid. A cell in the mth row and nth column is denoted as cell m, m into n. Any number cannot be repeated within a row or column. So you can see here. So the basic idea of this puzzle is, if the puzzle is of 6 into 6 grid, right? So we can use 1 to 6. I mean, all the information is given in the rules also, but in general I am talking about, if this square would have been 1 into 5, 5 into 5, so you can use numbers from 1 into 5. Okay, if it is 7 into 7, you can use number from 1 to 7. That is the basic rule here, which is also written in the question. So because it's a 6 into 6 grid, we can use numbers from 1 to 6. Okay. A mathematical operation region is defined as the region enclosed by bold lines boundaries. There is a number and a mathematical operation symbol associated with each mathematical operation region. The regions with only one cell have only the number and mathematical operation symbols. So you can see here, this is one region, this is one region, this is one region, this is one region. Okay, so you can see in every region we have a number and symbol. So the idea is simply that for these three numbers the product should be 72. For these two numbers the difference is 1. For these two numbers, when you divide one of the number by the second one, the answer should be 2. Sum of these two should be 7. Division of these two should be 5. If you divide one of the number by another number, the quotient must be 5. Okay. Sum of these three will be 12. Difference of these two will be 5. This is 5 fixed, this is 1 fixed, this is 3 fixed. Similarly, this into this should give you 24. Okay. I hope the logic is clear, right? Which is explained here also, right? The number associated with each mathematical operation region is the result of the mathematical operation among the numbers present in the cells of the region. The number gives either the sum, division, multiplication or difference between the numbers present in the cells of the region. For example, the dotted, we have discussed this, right? Bold line region of 5 into 6 into 6 have a difference of 1 between the cells, right? The numbers are allowed to repeat within the bold lined operation region as long as doing so does not break the rules of a number cannot repeat within the same row or column. Okay, for all the regions with the division and subtraction symbol, there were exactly 2 cells in this region, which is clear, right? Okay, so the idea is that, I mean, for these 4, the numbers can repeat as in this region, right? As long as in same row or same column, same number is not being repeated. All right. Okay. So where can we start from this? We have 5, 1 and 3 fixed. Okay. So we have 3 numbers in this row. Let's try to figure it out. So we are left with 2, 4 and 6. Now product of these two should be 1. That has to be 2 into 1 only. 1 is already here. So can I say 1 will be here and 2 will be here? There is no other choice, right? Okay, 1 into 2 is fixed. What else we can do like this? Look at this. Division of these two should be 5. That is only possible 5 by 1, right? 5 upon 1. So either of these two will be 1 or 5. But 1 is already here in this column. So 1 cannot be here. So it has to be 5. It has to be 1. Are you getting it? Okay. Alright. What else we can do? Can we find any other things like this? Division of these two should be 1. Sorry, it should be 2. That is possible by 4 by 2, 2 by 1, 3 by 6. Okay. 6 by 3, sorry. 3 is not already there, so it is not possible. So either 4, 2 or 2, 1. We are not sure about that as of now. Difference of these two should be 1. Sum of these. अभी तक कुछ नहीं पता लग रहा है, right? So let's try to make cases now. Product of these two should be 24. Alright. So it has to be possible, and because we have only two numbers here, so 4 into 6 is the only possibility. So either 4 or 6, 6 or 4 will be here. Okay. Alright. In this row again, we are left with what? We are left with 4 and 6. Okay. But anything can come here, right? So I can say either 4 or 6 will come here, or 6 and 4 will come here. Okay. Yeah, let's remove the extra part also, so that you can understand it better. Alright, moving on. In this column we have 5, 1, 4 and 6 will be here only in any order. So we are left with 2 and 3. Okay. So here and here, either of 2 or 3 will be there. Can we put 3 here? If we put 3 here, difference should be 4. So if I put 3 here, this has to be 7, which is not possible. Right? Basically, difference of these two numbers should be 4. But if you put 3 here, it has to be 7, which is not possible because 7 cannot be used. That means, can I say I cannot use 3, I have to use 2, and this will be definitely 6 in that case. Is it clear? Difference of two numbers is 4 is only possible with 6, 2 and 5, 1. 1 is already here, so I cannot put there. Okay. So this case is ruled out. I am only left with 6 and 2. And 6 is definitely in this column, either of in these two cells. So 6 cannot be here. It has to be 6 and 2. So what is left now in this column? We are left with 3, right? So 3 will put here. Sum of these two should be 7. So this has to be 4. If this is 4, this cannot be 4, right? So this has to be 6. If this is 6, this has to be 4. Clear so far? Okay. Alright. Now, this 6 is fixed here. Product of these three should be 72. So divide by 6 gives you 12. So product of these two should be 12. 12 is possible with 2 into 6, but 2 and 6 are already in this row, so not possible. 3 into 8, not possible. 3 into 4, right? 3 into 4, yeah. 3 into 4 is possible. Right? Can I say only possibility is 3 into 4? So that the product is 12, right? Now because 3 is already here, so it has to be 4, it has to be 3. Right? Okay, now in this column, if we talk about what is left, 2 is left and 5 is left. Okay, as of now anything can go anywhere because sum is 7, 5 plus 2, 2 plus 5, anything can be done. Okay, and 6 plus 1, is it possible? Sum 7 can be possible with 6 plus 1 or 5 plus 2. 6 plus 1 is ruled out because we have 6 and 1 here, so this is not possible. 5 plus 2, if you put 5 here and 2 here, look at this. It is either 4 by 2 or 2 by 1. I mean either it is 4 2 or 2 4 in any order. So 4 2 तो नहीं होगा, 2 4 ही होगा. Or it could be 2 and 1, and 2 and 1 means 1 here and 2 here. But either ways, in any of the cases, 2 will be used, right? 2 is definitely used in this column if you take any of the case. So I cannot use 2 here. Are you getting the point? I repeat, if I say 5 and 2 here, for division of two number is 2, the only possibility was 4 and 2 and 2 and 1. So in either of the case, 2 will be definitely used in either of this or this column. So in this column, 2 is used here, okay? So I cannot use 2 here. So that means this has to be 5 and this has to be 2. And in that case, this is left with 5. Okay. Difference of these two should be 1. So either 5 4 or 5 6. 4 is already used here. It has to be 6. Okay. If this is 6, this cannot be 6. So this has to be 4 and this has to be 6. Alright. Any doubts so far? Okay. Now, what is left here? Only one number is left here, right? 1 is fixed, 2, 3, 4 is fixed, 6 is fixed, 5 is left here. If 5 is left here, we are left for this sum 12, we are left with the 3, that is only possible 1 and 2 and 2 and 1. So we can say these two should be either 1 2 or 2 1. Okay. So in this row, 1 or 2 will be fixed here in any order. 4 is there, 5 is there, 6 is there. The only possibility left is 3. And difference of these two is 1. So either 3 4 or 3 2. 2 is already used here. It has to be 4. I hope we are getting it. Okay. Now what is left here? We have 1 left in this row and we are left with 3. So either 1 or 3 will be here and 3 1 will be here. Okay. Now look at this. Or you can fit this also. 1 2 3 4 is fixed. We are left with 5 and 6. Difference is 1. That is okay. But 5 is used here. So 5 cannot be used in this line. It has to be 5. It has to be 6. This is also fixed. Alright. And 4 2 3 2. 4 2 or 2 1. Okay. Anyways, 4 is used here, right? So it has to be 2 and 1. And 1 is already in this line, so it has to be 2, it has to be 1. Almost done, right? Okay, now difference of these two is 3. We have, I'm not sure कि हमने क्या use किया है. One point is clear. If I use, let's say, 1 here, so 2 will be here. In that case, 1 cannot be used here, 1 will be here and 3 will be here. And in another case, if I put 2, it will be 1, it will be 3, it will be 1. So can I say in these two cells, 1 is definitely used either here or here? I am not sure about 3, okay, is used or not, but I am pretty much sure 1 will be either here or here. So I cannot use 1 here. Okay, difference of two number is 3. What are the possibilities? 1, 4, 2, 5, 3, 6. 1, 4 is ruled out because 1 will be used here. 2, 5 is ruled out because 5 we have already used. So the only possibility left is 3 and 6. And because we have used 6 here, so 6 will be here and 3 will be here. Got it? And because 3 is here, I cannot use 3 in this one. So this has to be 1. This has to be 3. If this is 1, this is 2. And this is 1. Everything fixed, I think. Oh, one thing, this is left. So that is okay, I think. In this row, we have used 1. 2 is not used. So 2 will be here. And here we have 4. Nothing is left, right? Everything is done. Alright, now the question will be easy, right? Because all the question will be based on this only now. So this is what we got. What is the sum of row numbers of the 6's in columns 1, 3 and 5? Column 1, column 3, column 5. 6's in 1, in 6 and in 5. Sum of row numbers 1 plus 5 plus 6, that is 12. Yeah? Easy now, right? 7th. What is the difference between the sum of numbers in the two largest diagonals of the grid? Two largest diagonals, 6, 4, 2, 6, 4, 5, 2, 3, 1, 1, 1. Just add it, subtract it, you will get your answer. Answer will be 15. Alright. Next, the two mathematical operation regions with the largest and second largest values of x for the operation region x minus are selected. So x minus type के हमने two mathematical operation we have selected with the largest and second largest values of x. Okay. Which of the following is the ratio of sum of the two numbers in the region with the second largest values of x to that of largest value of x? Let's look at the figure. थोड़ा सा ऊपर चला गया. It's okay. So we need to find two biggest difference of x minus type के largest and second largest. What are the values we have in minus? We have 3 minus, we have 4 minus, we have 2 minus, we have 1 minus, we have 1 minus, we have 1 minus. That's it. Clearly the two largest are 4 minus and 3 minus. Correct? So we are taking this region and this region. Which of the following is the ratio of sum of the two numbers in the region with the second highest to the highest? So second highest was what? This one. In this, the sum of the numbers is 9. Largest x is 4. In this one, sum of the numbers is 8. That will be your answer. 9 is to 8. Alright, clear hai? Ninth, which of the following statement is true? Statement A, sum of the row numbers of the cells with 5s for the first 3 columns were more than that of the last 3 columns. Statement B, two largest diagonals of the grids have total 2 5s. Let's check. First statement. The sum of row numbers of the cells with 5 in the first 3 columns. First 3 columns, 5s are this, this and this. Row numbers are 3, 4 and 2. this sum is 9, right? And the statement was saying more than the last 3 columns. Last 3 columns you can see it is this, that is 5, it is 6 row number, and 1, which is 12. So this is 9 and this is 12. The statement was saying this is more than this. Not possible. The first statement is false. Second, the two largest diagonals have 2 5s. In this we have 0 5. In this we have 1 5 only. So this is also false. Neither of the statement is true. Alright. Okay, next question. Which of the following statement is false? Okay, let's check directly. Column 5 has a difference of 4 between the last row and the first row cell. Column 5 has a difference of 4 between the last row and first row cell. True? Second statement. Among the columns, column 1 has the maximum difference between its last row and the first row. Sorry. 6 minus 1 is 5. Here we have 1. Here we have 3. Here we have 2. Here we have 4. Here we have 1. Clearly this is largest. In any ways 5 is largest difference, right? Minimum and maximum. So clearly no need to check for others. But the statement is true. See, among the columns, column 2 is the one with the one of the two columns that has the least difference between its last row and first row column. So 3 minus 2, 1. Here we have 3, here we have 2, here we have 4, here we have 1. So among all the columns, column 2 is one of the two columns. One of the two columns, right? That has the least difference. So we have two columns with the least difference. In that one, column 2 is one of the two. So that is also true. Let's check last also to be sure. Row 6 has the maximum difference between its last column and first column cells among the rows. Okay. Here we have difference of 3. Here we have difference of 1. Here we have difference of 3. Here we have difference of 4. Clearly not maximum, because you can clearly see 4 here, right? So this statement is false, and that's your answer. Because the question was which of the following statement is false. Alright, are we clear with the second set? Okay. Now this is also doable if you are, pretty sure about the logic about the Sudoku and such kind of puzzles, right? In newspapers, such kind of puzzles appear on a daily basis. Sudoku, Kakuro, Loop the Loop. I think this puzzle is also there in one of the newspaper. Okay, you can check for these type of things. Okay, that can be there. All right.